Hello everyone, welcome back to Smart India's YouTube channel. My name is Ankit Patel and today we are going to discuss the Codeforces Round 950 problems. So let's begin with the very first problem. First problem is problem generator. So in this problem it is given that Vlad is planning to conduct M rounds next month. Each round should contain one problem of difficulty levels A, B, C, D, E, F and G. Vlad already had a bank of n problems where the ith problem has a difficulty level of A of I. There may not be enough of these problems, so he may have to come up with a few more problems. Vlad wants to come up with as few problems as possible, so he asks you to find the minimum number of problems he needs to come up with in order to hold the M rounds. I hope the question is clear. Vlad planning to conduct the M rounds next month. In each of the rounds, he wants at least one problem of difficulty levels from A to G. He is already having a set of n problems with him with the difficulty levels given. But he is sure that he might not be, or he knows that he might not have the enough of the problems to conduct the M rounds. He need to add a few more problems. He wants to find the minimum number of problems he need to come up in order to hold the M rounds here. Here example is also given. For example, M equal to 1. Round number of rounds he wants to conduct is 1. N equal to 10. That means he is having 10 problems with him. Along with that, he is also given the problems difficulty levels. Then he needs to come up with at least two problems here. One of difficulty level A and one of the difficulty level F. Because if you look at, he wants to conduct one round. That means whatever the problems are there of difficulty level from A to G should at least present one time in his set of problems. But if you look at, A is not there, along with A, F is also not there. So here he need at least two problems to come up with. I hope the question is clear. Next, in the input format, first line number of test cases, which is 10 power 3 maximum here. First line of every test case, two integers are given n and m, where maximum value of n is 50 and the maximum value of m is 5 here. N is nothing but the number of problems in his bank and the m is nothing but number of rounds he wants to conduct. Second line of test case contains a string A of length n with the problem of difficulties from A to G. Before we move further discussing the logic and coding it up, I want you to pause the video, go through the entire problem once, try to see it is a very straightforward problem. Try to come up with the logic, and if you are able to come up with the logic, code it up as well. Okay, now let's see the sample input and output here. First one we have already seen. Okay, coming to the second one here, two things are given. One is m and here it is n. N is nothing but number of problems he is having. Here problems difficulty level as well given. Here he wants to conduct two rounds. Now when Vlad wants to conduct two rounds, can I say that if he wants to conduct two rounds, I should he should at least have problem difficulty level A. He should at least have two problems of difficulty level A. He should at least have two problems of difficulty level B, two problems of difficulty level C, two problems of difficulty level D, two problems of difficulty level E, two problems of difficulty level F, and two problems of difficulty level G. If these problems of difficulty level are there, then only he will be able to hold the two rounds here. This is the required, I can say. This is the minimum required number of problems. He required at least two problems of difficulty level A, B, like all these things. Now, but what he is having, can I say, here if you look at, he is having a, how many problems do we have of difficulty level A? 0 he is having along with like B. What is B here? How many problems he have with difficulty level B? Only 2. What about C? C as well as 2. D, D 3 he is having. E, number of problems with difficulty level E. 2 he is having. F, 0. G, 1. So how many minimum number of problems he required such that he can hold the M rounds here? Can I say that here he required 2 but he's having 0. So initially my answer will be 0 here. Now when requirement is 2, he is having 0. Can I say that I need to add 2 more problems? B, he's having the enough problems. Requirement is 2, he's already having 2 in his bank of difficulty level B. Same with C as well. Same with D as well. Requirement is 2, he's already having 3. So more than enough. Same with E as well, enough. But if you look at the F, requirement is 2, but he's having 0. So can I say that I need to add 2 more problems here? And if you look at the G, requirement is 2, but he's having only one problem with difficulty level G here. So, okay, my bad. Here it should be 4. Next it will be 5. 4 plus 1, 5 here. So total he requires to add 5 more problems here, which is nothing but our output here. Simple problem, I guess. This already is fixed 2. What is 2 here? 2 is nothing but M here. We require each and every problem at least M of each and every difficulty level. Yes or no? But this is what he is having. How do I get this? Whatever the problems, how many problems he has of any particular difficulty level, how do I get this? Simply finding the frequency of each and every character from A to G in the given string here. How many ways do we have to find the frequency? That you know. See, simple one thing we can use is map. To find the frequency, I can use the array as well. Frequency array, count array, anything we can say it. Once we get the frequency of the string, frequency of each and every character in the string, I can simply check, compare with the M here. Can we proceed to the code? What all given in the input here? Number of test cases will be given. Next one is after the number of test cases, I will go to each and every test case here. I will read the number of problems he has and the number of rounds he wants to conduct. String S, I would say. String S, C in S. Now I need to declare vector just for frequency of each character from A to G. I will say this as frequency array of size 7, as I need only the frequency of A to G. Initially everything as 0. Now I will go to each and every character. Next I will go to each and every character. I will say that frequency of, what should I write? Here frequency of S of I. But if I directly write S of I, what will happen? You know that we are having a frequency of size 7. We want to store the uppercase A. So I have to here, I can write minus 65 or I can offset by uppercase A as well. After that, once I have this thing, now I am having this thing in my frequency array. And it will be looking something like, this is our frequency array of size 7. Here 0, here we'll be having frequency as 2, frequency as 3, 2, 0 and 1. I just need to see if it is 2 or not. Is it 2? No. So in my answer I will add 2. 2 it is already there. 2 it is already there. 2 more than 3 is there. So more than enough. 2. Is it? It is less than 2. So I will add 2 into my answer. Here it is less than 2. So I will add M minus whatever the number is there. Do the same thing. I will go to each and every frequency here, each and every character you can say, and I will say that okay, before I add into my answer, I need to initialize my answer as well. Int answer equals to 0, next answer equals to what I need to write, m minus frequency of I. But there's a problem if I directly write m minus frequency of I. The problem is when I'm here, m is 2 here. You know that here for this problem m is 2. Now if I do 2 minus 3 here, frequency is 3. If I do m minus 3, 2 minus 3, I will get minus 1. See, I'm having more than enough. It doesn't mean that I will remove a problem. No. Here in my answer, it should add is 0. So whenever I get a negative, I will update with 0. To do so, I will say that if anytime I'm getting my m minus frequency of I as negative, compare it with 0. Next thing would be C out. Here I need to do the increment every time. C out answer endl. Let's get the test cases here. Then we'll be selecting C++. Fine. Let's run the code. Simple thing, whatever we have discussed, I'm doing that only. 251 expected as 251 only. So I will copy this, submit code here, submit. We need to select the problem as well, and we will submit. Yeah, accepted. So first problem is done. Okay. Let's see the second problem, that is choosing cubes. Dimitri has n cubes numbered from left to right from 1 to n. The cube with the index f is his favorite. Dimitri threw all the cubes on the table and the ith cube showed the value ai, which is in the range from 1 to 100. After that, he arranged all the cubes in a non-decreasing order of their values from largest to smallest. If two cubes shows the same value, they can go in any order. After sorting, Dimitri removed the first k cubes. Then he became interested in whether he removed his favorite cube or not. It is also given that note that its position could have changed after sorting. I hope question is clear. N cubes are given, like Dimitri has n cubes numbered from 1 to n. Cube with the index f or position f is his favorite. Dimitri threw all the values on the table. After throwing all the tables on the value, it shows some values. Each and every cube shows some values. He arranges all the cubes in the non-decreasing order from largest to smallest. If any two cubes have the same value, they can go in any order. But after sorting, Dimitri removes the first k cubes. Then he wants to know whether he removed his favorite cube or not. That is the straightforward question. In the given example, n equal to 5, that means 5 cubes are there, and favorite cube is cube at position 2 here. Cube at a position 2 is its favorite. After sorting, let's suppose this is the sorted value. Okay, this is the sorted value. Then he need to remove the first k cube. If its favorite cube is this one, and if we remove it, what will happen? Since the favorite cube ended in the second position, it will be removed. It may also happen that its favorite cube can be in the third position, and I am removing the first two cubes. It will not be removed. So here it's a case of maybe here. Okay. Let's try to see the sample input and output. Input format, number of test cases will be given. Here maximum number of test cases can be 10 power 3. First line of each and every test case will be 3 integers, will be given 3 integers n, f and k. N is nothing but number of cubes, f is nothing but favorite position of the cube, k is nothing but after sorting how many cubes to be removed. Second line contains the n integers showing the values of the cube. Output format, we need to print if the cube will be removed in all the cases. No, if cube will not be removed in any case. Maybe either removed or left. Okay, already the first one we have seen. Before moving further, we see the logic and code item. I want you to pause the video, go through the question once, try to see if you are able to get any logic. If you're able to get any logic, please try to code it up as well. Okay. Let's see the logic part here. First one we have already seen. Output as maybe. Let's try to see the second test case here. Values given as something as 4, cube values 4, 2, 1, 3 and 5. Favorite cube, which is its favorite cube? Nothing but this is K, this is F and this is N. So favorite cube position is 5 here. That is nothing but this one. Favorite. Let's sort it. If I sort it, what values will be getting? Something as 5, 4, 3, 2, 1. Now, can you guys tell me which cube, what is the position of cube after sorting? Nothing but this one. What is the position of favorite Dimitri favorite cube after sorting? First one. How many cubes I need to remove? I need to remove the first 3 cubes. And here what is happening if I am removing first 3 cubes? His favorite cube is getting removed. So here I need to print the answer as yes. In the same way, let's try to look at the third test case as well. K, here N is given, F is given. Values are something as 5, 2, 4, 1 and 3. Favorite cube, here favorite cube will be at the position 5. So this is the favorite cube. Let's sort it. So here, let's sort it here. 5, 4, 3, 2, 1. Now, after sorting, can you guys tell me the Dimitri's favorite cube position? It is at the index. Here, 3 only. This is the favorite now. Here it is positioned. How many cubes I have to remove here? First 2. It is asked to remove the first 2 cubes. Now, if I remove the first 2 cubes after sorting, will the Dimitri's favorite cube will be removed? No, it will not be removed. So when it will not be removed, our output would be simply no here. You are able to get the logic as well. What I am trying to do, whatever the given array is there, with the cube values, I am sorting it. I am trying to check for the first k values here. Can I say that this is the first k values? These are the remaining values from k to n. Here same thing. 0 to k I can say, and this is from k to n. First k values, these are from k to n values. Now, if favorite cube value present in this range, if it is present in this range, it will definitely won't be removed, yes or no? If it is present in this range, it will not be removed. Here we have already seen it was favorite cube was present in this range, so it was removed and printed as yes. When it is not present in this range and it will not be removed, I will print it as no. But there is one more case that can happen. There may be a case that favorite cube, whatever is there, it can be present in this range as well, this range, and it can present in the second range as well. Okay, removed range, not removed range. It may present in both the things. You may think how that will happen. Let's suppose f equals to 3. There are multiple 3's, let's say. Instead of 4, I am having 3 here. Now what will happen? Here also I will be getting as 3. Now if you look at favorite cube is present in the removed range as well. It is present in the non-removed range as well. So in this case, our answer will be nothing but maybe here. Maybe. Okay. I hope the logic is clear. Check the first k. Is it present or not? Favorite cube. Check the k from n. Is it the favorite cube present or not? And get your answers. Let's try to code it up. Number of test cases I have already read. Okay, next. Okay, let's try to take the test cases here so that it will be easy to read it. N, F and K. N, F and K. Next thing is I need to create an array of size n. I will say C in array of I. Next thing would be I need to sort it. Very first thing I need to do, sort it. How do we sort it? And how do we need to sort? We do not have to sort in ascending order. We need to sort in a descending order. That means when I want to sort in a descending order, I need to write here greater int. I need to keep the braces. No. What all thing we require? What is the favorite cube here? I can say favorite cube equals to array of f minus 1. Why I'm writing f minus 1? If you look at the problem, whatever the cube position is given, it is given in 1 based indexing, and whatever the cube values we are taking in a 0 based indexing. So I'm made f minus 1. No, I will go to, before that I need to declare, I will declare two more values as well. Definitely remove, I will say definitely removed equals to true, and one more, that is definitely not removed here. Definitely not removed here. Next, then I will go to int I equals to 0, I less than k. First k values I will be going. I will try to see if array of I equals to favorite cube or not. If it is favorite, what I will do? That means it is present in the first range. I can say it is present in the first range. When it is present in the first range, whatever our assumption was there here, definitely removed and definitely not removed. So definitely not removed assumption is going to fail. Yes or no? So can I say that definitely not removed, whatever our assumption was there, as it is present in the first one, this is going to fail. Yes or no? Definitely not removed, but it is present in the removed range. So this is going to fail. Definitely not removed. This one. Same thing I need to do for the second one as well, from k to n. Same thing I need to do for the remaining as well. Here I will say whatever our assumption, definitely remove assumption was there, but as it is present in the second part here, not removed range, like this one. So our assumption that definitely removed is there, that also becomes false. No. After that, I will check if my definitely removed is there. Definitely removed. Definitely removed is there. Can I say that when definitely removed, that means I need to print yes here. If that not the case, else if definitely not removed, when I'm sure that definitely it is not removed, see out no endl. If both are not true, if it is present in both the cases, what is the thing I need to print? Maybe. That is right, I need to print the maybe here. Okay, let's try to run the test cases here. Okay, maybe, no, no. Are we getting the same thing? Definitely remove, definitely not removed here. K to N. Hmm. Is it the expected output? Maybe yes, no, no. Okay, maybe no, yeah. Okay, it is not the expected output that we wanted. Where are we making mistakes? Yep, here we are making mistakes. So first we need to get the favorite value. After that we need to sort it. Let's try to run one more time. Maybe yes, no. Yes, 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 no. Okay, fine. It is matching with our expected output. So we can directly copy this code. Let's try to submit it. Second problem choosing here, C++. Let's submit it. So whatever we have discussed, we are doing the same thing, like we are trying to, and it has passed. Okay, that's it for the second problem. Okay, let's try to see the third problem, that is Sophia and the lost operations. Sophia had an array of n integers, a1, a2, so on, n. One day she got bored with it, so decided to sequentially apply m modification operations to it. Okay. Each modification operation is described by a pair of numbers Cj, Dj, and means that element of the array with index Cj should be assigned the value Dj. Okay. Here perform the assignment. A of index Cj equals to Dj here. After applying all the modification operations sequentially, Sophia discarded the resulting array. Okay. Next, recently you found an array of length n, let's say B array, B1, B2, so on, Bn. You are interested in whether this array is Sophia's array. You know the values of original array as well as the D1, D2, so on, Dm. The values are of C1, C2, so on, Cm turn out to be lost. Hmm. Is there a sequence of C1, C2, so on, Cm such that the sequential application of modification operations C1, D1, C2, D2, so on, Cm, Dn to the array A1, A2, so on, n transforms into the array B1, B2, so on, Bn. Okay, this is the entire question. In a simple words, if I have to tell you, the question is something like an original array is there. On the original array, M modifications are done to it. That is something like this. M operations look something like this: C1, D1, C2, D2, so on, Cm, Dm. So in each and every modification, what happens is A of Cj, whatever is there, A of Cj is there, this index, Dj value will be applied. Okay, that value will be applied. Here, after applying all the modification operation equally sequentially, Sophia discarded the resultant array. She discarded it. Now, you found an array B. Okay, you found an array B having the n values. Now, we need to find whatever the B array we find, is it the Sophia's array? See, what all values it is given. Values of original array is given. Values of D1, D2, Dm also given. Values of what we say, this is also given. See, resultant array is given, original array is given, values of these are given. Only thing that is lost is C1 values, nothing but index values are lost. Okay, now we need to find whether whatever the B array is there, is it the Sophia's resultant array or not. Okay, coming to the input format, number of test cases, first line number of test cases, that is going to be 10 power 4 maximum here. Now, for each and every test case, few things will be given. First one is n. Okay, first line of test case will be n. Now, after that, two things will be given to you. One is A array, one is B array. What is A array? Nothing but the original array. What is B array? Nothing but the found array or the resultant array, I can say. Now, after that, M will be given. M is nothing but size of the modification operations. Okay, and for M, you will be given the MD values will be given, D1, D2, so on, DM values will be given. What we need to print in the output for each test case, we need to answer yes if there exists a suitable sequence of CM, C2, so on, CM, such that if we apply to A, we'll be getting the resultant value as B. If no, we need to print no. That's okay. I hope the question is clear till here. If the question is clear, you can pause the video, try to think of a logic. And if you are able to get the logic as well, try to code it up. Meanwhile, let's see the first example here. Okay. First example, size of the array here. Okay. N. This is the A array, I can say. This is the B array. M. Values of D. Okay. Values of D are given. A array values are something like 1 to 1. And what is meant by A array here? Nothing but the original array. We are also given the B array 1, 3 and 2. What is meant by B array here? Nothing but the resultant array. Also, we are also given the M operations that are applied to A. But here C values are not given, only the D values are given, which is nothing but something like 1, 3, 1, 2. Okay. One thing we need to understand that if both the values of A and B are same, A and B array are same, we do not have to do anything. Yes or no? I hope that is clear, because both are same. I do not have to apply any modification operations. Coming to here, coming to the second index, as it is not matching, what we could do here if it is not matching? If I want my B array to be the resultant array, and what are the operations that could happen? A of Cj equals to Dj. Okay, and we don't know the value of Cj, so we can have an assumption that Cj could be anything. Okay, don't worry about the Cj. We need to look at, do the Dj value, whatever this value 3 is there, is it present in the this one D array? Is it present in the D array? We need to look at it. So let's say this is the D array, and we now have to see, now if I want to apply this operation, what is meant to be there? Whatever the B value is there, it has to be in the here. Is it there? Yes, it is there. So when it is there, what I will do? I will remove it, and I can say I have applied 3 here. Again, I will go to the next index. Are both the matching? Both indexes are not matching. Again, what will happen? To make A and B array same, there has to be some value 2 in my D array, such that what will happen then? A of index 2 will becomes the 2 here. This modification operation may have applied. A of 2 equals to 2. Then what will happen? Here it will become true. Here it will become 2. To make that happen, can I say that whatever this value is there, it has to be in my D array here? Do I have it? Yes, I have it. And done. So now if you look at what is happening here, whatever the B array is there, it can be the resultant after applying the M modification. You may have a doubt. See, we have skipped 1 and 1. No, we are not skipping 1. If you look at the problem, what is saying? If you look at the question, what is given here? Few things to be kept in mind. That is, we can apply. See, it may happen that first we have applied 1 here. Okay. After that we have applied 3. That can happen. That can be the possible case here. Here as well as same thing. First we may have applied 1, and after that we have applied 2. That means we are using all the operations. It is for sure guarantee that we have to apply all the modifications here. That is the thing we need to keep in mind here. And that is also sequentially. Here also see, if you look at operations sequentially here as well as such as the sequential operation of modification operations are given. That means sequential we need to apply each and everything. Okay. Let's look at the, okay. So for this example, first one, our output has to be yes. Yes. Okay, let's see for the second example, why it is no. Why it is no here? Okay. Same thing would be there. This would be n. This will be array A. This will be array B. This would be M size. And this is the D. Okay. What do I have in A? 1, 2, 3 and 5. B is 2, 1 and 2, 1, 3, 5. In D I am having something like 2 and 3. 2, 3 here. Okay. Are both matching? First one. Both are not matching. I'm going sequentially. Okay, both are not matching. ACJ equals to DJ. Possibly, as 2 is present, I'm not caring about the index. Is my B, when it is different, is my B present in the D? Yes, it is present. So can I say that I can simply apply 2 here? Yes or no? And both will be same here. What is the number here? 2. Okay. Now, again, both are not matching. When both are not matching, I need 1, but I don't have 1 in my D. Is it possible to convert A and B same? No, it is not possible. It's not possible when it is not matching and whatever the 1 is there, it is not present in the D. So it is not possible. I can say output for this will be no. Here our output was yes and here output is no. Okay, let's try to see the one more example, and after that everything would be clear. Fourth one here, n is given. I hope everything is clear. Let's try to directly take it. 3178. Okay. B is 27 and 2278. Sorry, 7, 10, 3178 and 22710. Values of D are 10, 3, 2, 2 and 1. Okay. Is the first one matching? Not matching. But as I said, if B is present in D, I can apply that operation. Okay. I will delete it here. I will say that here 2 will be coming. No. Is it matching? Not matching. But do I have B, the value 2 in my D? Yes, I am having. So I can apply that here as well. Okay. What about third one? Yes, it is there. See, applying the operation sequentially, as I mentioned, if there is something like this is A array, this is B array, it may happen that I can apply directly 10 here. After that, I have modified to 2, 3 as well. First, I will apply 3. After that, I can modify to 3, 2. That's not the big problem. We have to apply each and every repetition. Now, this is not there. Oh, this is same. So no need to do anything here. Different. When it is different, when it is different, when it is different, what should be there? I will be checking, is the B value there in D? It is there. So I will convert it to 10. Now it may look like 2 to 710. B resultant array as well, 2 to 710. Both are same and we found the answer. But if you look at the answer for the fourth one, it is no. And we got our answer as yes. Can you guys tell me what is the one mistake we are doing here? Try to figure it out. They asked us to apply the operation sequentially. See, we may have applied 10. After that, we have override by 2. Same thing. First, we apply 3, then override by 2. But what about 1? See, 1 we have to apply for sure. We are going in a sequential manner. And when the last value is 1, when the last value is 1, that means for sure one of the values will be changing to 1. And if I change any value to 1, both the A and B array will not match. So that is the edge case we need to see. Okay. Whatever is there before, that doesn't matter. But if you have whatever the at least one element at the end, which is present in the B array, then what will happen? I will override the values again and again. And every operation will be applied sequentially. So this is the edge case that I need to see. So when this is the case, when 1 is not present in the B, our answer here has to be no, not yes. I hope the logic is clear. Simple logic. We are not doing anything much here. If the values are different, I am checking if the B value is there in B or not. Okay. I am decreasing the value here. Let's say one more thing we need to check that. Last value of D has to present in B. And I told you why that as well. Because we are applying the operations sequentially. if I'm applying the operation sequential, it's not like if first I will apply this, then I will apply this. No, not like that. I am going line by line. So if any one of the value matches, what will happen? I'm applying this. When I'm applying this, when I come to here and this is matching, so what will happen? Applying this, and this all these things will be override by 2 here. But for 1, what is happening here? Already we have applied all the modification operations. It is matching, but 1, if I applied it anywhere, for sure I have to apply 1. And if I applied it anywhere, what will happen? Both will not match. So it is for sure has to be d of m minus 1 has to be present in B as well. Present in B. D of m minus 1 has to be present in B. That's it. Now we can go to the code part. Let's see the test cases here. What all given? Number of test cases already have taken. Int n will be there. After that, int n, int array of, okay, int a here. We will also be having the B array. What is A array? Nothing but the result. A is original array, B is nothing but the resultant array. For int I equals to 0, I less than n, I plus plus here. See in A of I. Here it will be B of I. I am able to read both the things. After that, A and B. We are also having M. So I need to read M as well. C in M. Creating the D array of length M here. For int I equals to 0, I less than n, I plus plus. C in D of I. This is done. We are reading the A values, B values and D values. Okay. I just need to know the frequency of the D array. So I can use the map as well. Okay. And one more thing. If you look at here, I told you I need to know if D of n minus 1 present in B or not. One thing could be I can store B array as well in map, and simple with the check condition, one if condition, this I could know. Or I could do one more thing. I can iterate in the entire B array and I can check that as well. But here I will be taking the map. I will create 2 maps here. Let's say I'm creating 2 maps. One is for the D count, D array count. One is for the B array count. Okay. Now first I will go to the I will insert all the values of B count here, B array, B count of what I say, B of I. I will do is B of I plus plus. This one is missing. Next, same thing for the D array as well. Here the length would be M, and this will be D of I. Okay, this would be D count of D of I plus plus. Now, after that, what I need to do? I need to go to the all the values of A and B. If it is not matching, if A of I not matching with the B of I, what I will do if A of I not matching with the B of I need to check if D count of B of I, whatever is there, is it greater than 0? If it is greater than 0, I will decrement the count, D count of B of I plus plus. If that is not the case, what I need to do if that is not the case? If that is not the case, can I say that I have to make my flag as flag equals to false, but I haven't declared the flag, so I will declare the bool flag as well. Flag equals to true. Okay, flag equal to false. This is the one of the conditions. See, I wanted something from the B, but that is not in D. We discussed one more thing. D of m minus 1 has to be present in B as well. So how can I check that? That check would be simple if B count of D of m minus 1, yes or no? If it is greater than, if it is equals to 0. See, if it is equals to 0, then also I have to make my flag equals to false. If flag, I will be printing yes, and then else see out no. I hope that's it. Let's run the code. Okay, something we have messed up, I guess. P of d of m minus 1, last element we have taken. Oh, here we need to do minus minus, not plus plus. Still, let's try to look at one more. Okay, still it is not matching. Okay, one more mistake here. It has to be m. Now let's try to run it. What is the expected output here? Yes, triple no, yes, no, yes. Okay, yes, no, 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 yes, no. Okay, matching. So I will just copy this, select the language, and submit. It is accepted. Done with the third problem. Okay, let's see the fourth problem, that is GCD sequence. In this problem, it is given that GCD of a two number x and y is the maximum integer z by which both x and y are divisible. For example, GCD of 36, 48 equals to 12 because it is the greatest common divider. Okay? GCD of 5, 10 is 5 and GCD of 7, 11 is 1. Christiana Christina has an array consisting of n positive integers. She want to count the GCD of each neighboring pairs of numbers to get a new array B called GCD sequence. So the element of GCD sequence B will be calculated using the formula Bi equals to GCD of AI comma AI plus 1 for all the indexes in the range from 1 to n minus 1. Determine whether it is possible to remove exactly one number from the array so that GCD sequence B is non-decreasing. Okay. B, or, B for all the indexes, Bi less than or equals to Bi plus 1 is always true. Okay. This is the question. And if I have to tell you the question in a simple manner, initially, what is the meaning of GCD that you already know is given. Second thing, Christina already has an array of n positive integers. She wants to find the GCD of all the neighboring elements and store it in some array B. Now, once after storing, she wants to know that is the B, whatever the new array B is there, constructed using the GCD of neighboring elements in A, is it in increasing order? If it is in increasing order, fine. If not, she wants to know that if I remove any one element, exactly one element from A, is it possible that whatever the GCD sequence B is there, array B is there, it will be sorted. So if you look at here in the example, A is given something like this, and if I construct the B array for this, it will be like GCD of 20, 6 would be 2, GCD of 3, 6 would be 6, 12 will be 6 here, GCD of 12, 3, 12, 3 would be 3 here, GCD of 3, 48 would be 48, GCD of 48, 36 would be 12 here. So 6 elements will be getting the 5 GCDs in the GCD sequence in array B. And if you look at it, my bad, here it has to be 3 again. It has to be 3. Now if you look at the B array, is it in sorted order, increasing order? No, it is not in increasing order. So what we could do here, if I remove 3 from here, what could be my original B here? Like B after it, 20, 6. My GCD will be 2. GCD of 6, 12 will be 6. GCD of 12, 48. 12, 48 would be 12, GCD of 48 comma 36 would be 12. And if you look at D now, it is in increasing order. So that is what Christina wants to find out. Okay, is there a possibility that if she removes exactly one element from A, whatever the GCD sequence of array B will be there, it will be in an increasing order. If we look at the sample input and output, sample input, first line number of test cases, maximum it is going to be 10 power 4. First line of test case, n will be given. Second line of test case, array will be given. Array elements will be given. Output, what is the output format here? For each and every test case, we need to print yes if we can remove exactly one number from array A so that the GCD sequence of B is non-decreasing. No otherwise. Okay, let's try to see the few examples here. Let's say this is my A array, this is my B array. Okay. Here I'm having few elements, 6 elements, let's say. How we are constructing the B array here? Whatever the result of GCD of these two elements will be there, that will be stored here. Whatever the result of these two elements, GCD of these two elements will be stored here. Same thing here. Same thing will be stored here. And same thing will be stored here. So one thing is clear. If we are having 6 elements in our array, we'll be having the 5 elements. That is one thing. Now, let's say I'm having few elements here, and if I apply my GCD, I will be getting some elements as, let's say, B1, B2, B3, B4, B5. And let's say one condition that everything, whatever, like for each and every element, B1 is less than or equals to B2, B2 is less than or equals to B3, here B3 less than or equals to B4, B4 is less than or equals to B5. Okay, this is satisfied. So when this is satisfied, I can directly say print yes. Why so? I will say I will remove this from here. I will remove the last element from array. So what will happen if I remove the last element from array? This will also be removed and this will still be sorted only. So I don't have to think much about this case. Okay, we do not have to think much about this case. If B is already sorted, I can simply print yes. Okay, I can simply print yes that B is in a sorted form or increasing order, because we can remove the last element of B also will be removed, entire thing will be sorted only. But what if B is not sorted? Okay, B is not sorted here. If it was a condition that B was sorted, but what if B is not sorted here? Okay, let's try to think that as well. What we need to do if B is not sorted? So it may happen something like whatever our result is there, it may happen that here it is less than or equals to, here it is less than, or here it is greater than, and here it is less than or equal to, something like that. Here it is failing. Okay, at these two indexes it is failing. Yes or no? This one and this one. This one, two indexes are failing. Can you guys tell me how these B3 and B4 are constructed? How the values are filled in the B3 and B4? Basically, these two elements GCD. Yes or no? These two elements GCD. These two elements GCD and these two elements GCD will be stored in B4. So can I say that because of these three elements 1, 2, 3, whatever our B is there, it might not be in the increasing order. These three elements will be affecting. Let's say call this one as x1, this as x2, and this as x3. Okay. Probably because of these three elements, in one of the three elements, it is that key our B, whatever the resultant B array is there, GCD sequence B array, it is not in the sorted form or increasing order. So after we got this, we can do one thing. This was our A array. We could do one thing. One by one, first remove x1. Okay, remove x1 from A. Again construct B. Again construct B. Check if B is sorted. One thing. Second, remove x2 from A, construct B, check if it is sorted. Remove x3, construct remove x3 from A, construct again B, check if it is sorted. So only these three conditions will be there. First condition, if it is already sorted, I can simply print yes. If any one of them, here if any one of them turns out to be true, if by removing x1 or if by removing x2 or if by removing x3, if you are getting the resultant output B in an increasing order, I can say that yeah, I am able to get the resultant output by removing one element from it. Or else, third one, after doing this thing and before as well it was not in a sorted form, I can print no that by removing exactly one number, we cannot create a GCD sequence of B in a non-decreasing order. Okay, I hope that is clear. If that is clear, we can move to the code part. We will see the remaining things there. Let's go to the custom test. So what all is given here? Int n will be there. Okay, let's try to here. We'll paste it here so that it will be easy for us. I am reading n next to scene n, creating an array of size n here. For loop, I will be reading all the array elements a of I. Now we need to create the resultant array as well. How our resultant array? As I said, if our A is containing 6 elements, B will having the one lesser element. So here I need to create B of size n minus 1 would be enough. Here I will be going to int I equal to 0, int I equals to 0, I less than n, I plus plus, not I plus plus, n minus 1, you would know that as well. Now here I will write B of I equals to GCD. This is the sorter form to find the GCD. Here I will say GCD of A of I comma A of I plus A of I plus 1 here. Once I get the GCD, I need to know if it is already sorted or not. So int let's say some index equals to minus 1, int I equal to 0, I less than n, I plus plus. Here I will be checking if my B of I, whatever B of I is there, B of less than or equals to B of I plus 1, then it's fine. I do not have to do anything. If that is not the case, B of I greater than B of I plus 1, so I would be saying my index will be equals to I and I will be breaking from here itself. Okay. Now, here we'll be having few conditions. If index equals to minus 1, that means that already B array is sorted. So what I told, if B array is sorted, we do not have to do all this thing. I can remove the last one here. I can remove the last one, and like that is how possible it is happening, and I can directly print yes here. So same thing I will be doing. I will be printing here yes. If that is not the case, what was the second condition here? Maybe it is possibly due to x1, x2 or x3 elements. So I need to remove first x1. I need to check by removing x2 as well. I need to check by removing x3 as well. So same thing I will be doing. Else if I will be telling, okay, first let's write it here. Let some function x remove where I will be passing my index. I will be passing the size. I will be passing the array as well. If this is true, by removing this or by removing this or by removing these three things, index plus 1 or index plus 2, I am able to get it. I will say still I am able to get my results enter. If that is not the case, I need to print no here, no, enter. If you look at, we are doing one mistake here. Here it should be n minus 2. Okay, now let's write the remove function here. Remove where I'm having my index, basically I'm having the size, I'm having the array. That's it. Here array, here as well as ARA, AR. Now, after removing an element, I need to check whatever the resultant GCD sequence is there, is that in sorted form. So first I will construct one C array of size n minus 1. Now I will say that construct my, okay, I need to get the index as well. I will say some index j equal to 0. Here int I equal to 0. I will go till n I plus plus. I will skip this element. How to skip this element? If I say if I equals to index, I will continue, or else I will say C of j plus plus equals to C array of j plus plus equals to A of I here basically. So I am storing n minus 1 element, I am skipping one element, so it will be fine. Now I need to check if C is sorted or not. How to check? I can maintain one last, let's say some last equals to 1. I will be going till C equals to 0. I less than how much I should write? I minus 2, I plus plus here. I will be checking if whatever the GCD I will be getting adjacent of C. Till now in my C, what is there? In my C, apart from the x1 or x2 or x3, all the elements are having. So first I will find the some GCD. GCD I will be finding. How do we find the GCD? GCD of here I will be telling it as C of I comma C of I plus 1. See, I could have done one more thing. I could have stored each and every GCD in a separate array and again I could check. But I don't want to do so. Here only I wanted to know if whatever the values are there, GCD values, they are sorted or not. So here I will be saying if GCD, whatever we are getting, if it is greater than or equals to last, okay, my last will be G. If that is not the case, I will be returning false from you. Return false. If all the things are correct, I will be returning true. Let's try to run our code once. Yes, no, yes, no, yes, yes, no. Okay. I think everything is correct.
So as you can see, our expected output is matching here. So we'll just copy this code and we will try to submit GCD sequence. Yeah, it got accepted. That's it.
I hope video was informative. If so, share the video with your friends. And for more such content, do like, share, and subscribe to our Smart Intelligence YouTube channel. Until next video, this is Ankit Patel signing off.